Broadcast is now starting. All attendees are in listen-only mode.
Hi everybody, thanks for joining the webinar today. This is Ian Sharp from ATIS. We will just give 1 minute for people to get connected and then we will start with the introduction. So just hang on in there and we'll be with you in a minute. Hi everybody, thanks for joining the webinar today on 5G standards development in 3GPP release 16 and beyond. Go to the first slide please. This is Ian Sharp, Principal Technologist at ATIS, and we have a distinguished line of speakers available today. So after my opening remarks, we will hand over to Greg Schumacher from T-Mobile USA, who is 3GPP SA and SA1 Vice Chairman, who is going to talk about services in 3GPP. Following Greg, we will have Puneet Jain from Intel, who is 3GPP SA2, that's the Architecture Group Chairman, who is going to talk about systems architecture and core networks. And then we have Wansi Chen from Qualcomm, who will talk about the radio access network, and Wansi is the 3GPP RAN 1 Chairman. So we really have really excellent knowledge and 3GPP and some important 3GPP leaders to talk to us today. Lastly, I will give some closing remarks on the long-term outlook, and then we will do Q&A. So in order to give all the speakers time to cover their material, we'll do Q&A at the end of all the talks. If you have questions, then please submit them, and you can do that as we go through the presentation using the question box. We'll also try and keep an eye on the chat, but there is a particular question box on your screen. Next slide, please. The webinar today is organized by ATIS, and ATIS is a founding partner of 3GPP and the organizational partner for the North American region. 3GPP was founded to recognize the value of globally aligned standards, particularly the economies of scale and the benefits for users that emerge from those, but also to incorporate regional needs into the standards. In ATIS, we have a broad membership of both traditional telecoms interests, but also verticals and new internet-oriented players. Collectively, this group brings great technical expertise and regional representation into 3GPP. Compared to previous generations, 5G has attracted a lot of interest from government, both for their own applications and because of its strategic economic importance. ATIS has a long history of developing cooperative solutions between industry and government, and we see this aspect as important to the successful evolution of 5G standards. In ATIS, we work with our membership to make sure 3GPP incorporates North American requirements and technology proposals. Next slide, please. Since its foundation, the majority of work in 3GPP has been done in face-to-face meetings. COVID-19 has put a stop to that, and currently we are assuming that work will continue to be fully online through at least the first half of 2021. We've gone from a world of full meeting rooms to full inboxes, effectively. Thanks to the leadership and the delegates, 3GPP has adapted amazingly well to fully online working. I think it's fair to say that the productivity has been better than many people expected, but clearly not as good as face-to-face meetings. Apparently, hotel corridors and bars have special properties when it comes to reaching technical decisions. To be serious, I hope that as technologists and industry leaders, we will learn from our experiences about the limits of online working today. and that will help us improve technical solutions in the future, which will lead to better online collaboration, particularly for these very large global groups, which I think can be particularly difficult to work online. In the meantime, we are still making improvements in the working methods and the tools that we're using to do online work in 3GPP. And I'm sure that some degree of online work will outlast the current crisis. Next slide, please. I have one message, sorry, I have one message on the chat saying there's no sound. Can somebody from the organisers please check that they can hear okay?
This is Katie, I can hear you.
Okay, so I think if you don't have sound, then it might be at your end. Sorry about that. Wanshi kindly let me use a few Qualcomm slides to show how 5G is evolving. A fundamental difference between 5G and previous generations is that from the start, the vision of 5G was not just limited to mobile phones, but includes features like IoT, industrial applications, and private networks. As 3GPP specifications evolve, we are fleshing out these capabilities into the standard. Next slide, please. "5G has achieved significant market momentum despite COVID-19. We are seeing 5G connections growing at a faster rate than 4G, leading to the impressive numbers that you can see on this chart. I think this is really remarkable given the whole economic and social situation at the moment. Next slide, please. So lastly, let's look at the 3GPP release structure. The first release of 3GPP standards for 5G was release 15. This year in July, we froze release 16, which I think is a significant achievement considering COVID-19. The focus of release 16, as we will hear in detail later, is to extend the 5G platform capabilities, particularly for vertical, private, and industry applications. Release 17 standardization is now well underway. The original goal was to freeze release 17 at the end of 2021, but the release dates will be replanned this December due to the impact of COVID. The likely revised freeze date will be sometime perhaps around mid-2022. The goal in release 17 is to further expand the capabilities and commercial use cases of 5G, and we'll touch on some of those features, particularly in the services presentation. Beyond release 17, we will certainly see further enhancements to 5G capabilities. Release 18 requirements are already being studied, and we expect the release 18 timetable to be defined soon. With that introduction, I'd like to start with the first of the main speakers and hand you over to Greg, who will talk to us about 3GPP services. Thank you, Greg.
Thank you, Ian. What I want to talk about today is not to delve deeply into any of the services themselves or even the verticals that we're developing in 3GPP, but to give you an overview of how we came to where we are today and where we're going in the next few releases. So you get a sense of how does 3GPP develop and enhance the 5G capabilities. Next slide, please. So starting at the beginning of our effort of looking at the service definition for 5G, we started with a project called Smarter. And we did a study in release 14 to collect various requirements for what the services that 5G needs to support would look like. Next slide, please. So we started out, and there were a number of white papers from various worldwide organizations. Here they're shown. And in addition, we also took in contributions from individual participating companies. And we came up with a overview of where we thought that 5G needed to begin. And so based on what was contained in those white papers and other company contributions, we consolidated them down into 74 use cases, and we developed potential requirements for each of the use cases. And these potential requirements were things that were the requirements for 5G services. Next slide, please. So once we had all those potential requirements, we decided to organize them into 4 major areas: massive IoT, critical communications, enhanced mobile broadband, and network operations. And what we did was we took the potential requirements for each of the use cases and organized them into these 4 areas and further consolidated them. So essentially, duplicates or common requirements were merged together into these 4 conclusions and recommendations on the services that the initial version of 5G should support. Next slide, please. So this is kind of a quick overview of what each of the 4 areas covered. So the massive IoT was supporting much larger numbers of IoT devices than were supported in 4G, with the idea that the communication could range from simple to very complex. And in that category, there were non-time critical communications, such as smart wearables and things like that. Then we came up with the critical communication segment, which is not just for public safety, but also for commercial use, such as factory and process automation, VR, AR, and mission critical. And within that category, the requirements range from use cases that had higher availability, higher reliability, lower latency, up to ultra high reliability, ultra high availability, and ultra low latency. In the enhanced mobile broadband area, the areas that were considered for requirements were larger range of data rates, larger density ranges to support very sparse areas in an economic fashion to very dense deployments. Increased coverage in environments that were challenging in previous release of technologies such as 4G, such as indoors and other challenging environments. And then it was viewed as important to consider higher user mobility than was supported in the past. Then we had network operations, and these are really things that support the other 3 categories, but were viewed as important to allow operators to flexibly, economically, and scalably support the requirements and capabilities for these other areas. So things such as slicing to serving and differentiated market segments and differentiated verticals, the scalability, increased variety of mobility scenarios, such as fixed wireless, mobile wireless, and other scenarios like that. Self-backhauling was also an important capability that was added, and increased access options such as satellite access. Next slide. So what we did is, once we had all these requirements, proposed requirements agreed, then we and we separated them. Then we consolidated them back into a single specification of, which is the normative service specification, which describes all the mandatory requirements for 5G services. Next slide. So that gave us the baseline for 5G services. And then following that, we started looking at extending that as additional verticals, additional requirements, additional needs, operator needs were introduced. Partly because now we had a base to build upon, but also there was a limit to how much we could cover in the initial release. So next slide, please. So release 16 and beyond is really about, from a service perspective, extending the 5G service capabilities. And so this is an overview of, now that we have a baseline of service, 5G service to build upon, how do we go about adding new requirements or new verticals into the mix of what is supported by 5G services and 5G networks? So initially, we will identify a feature, a capability, or a vertical segment for 5G support, which has not been, which is not supported in the previous releases. We will collect illustrative use cases which demonstrate or show key aspects of that service that need to be considered for support by 5G networks and technology. And along with those use cases, there will be proposed service requirements and KPIs. Then we will consolidate these proposed service requirements and KPIs, and then categorize them by, are these service requirements and KPIs currently supported by 5G technologies, or is it not supported by 5G technologies? So based on the study, we will then work on adding the normative service, adding as normative service requirements and KPIs, those from the study which are not supported by current 5G specifications. Now, in some cases, there's not a direct mapping because they're as part of the consensus building and negotiation in standards, some or of the requirements and KPIs may get modified or even dropped from the study into normative requirements. Next slide, please. So this gives a quick overview of what was added for new services and new verticals in Release 16. So from verticals, we added support for industries using cyber physical control real time, such as industrial processes and factories, where timing of the interaction is critical, and also support for some existing LAN real-time protocols was also important. Support for railways. Now, railways had been supported, I believe it was in GSM, but there was a desire by certain railway segments to upgrade their railway network technology. Maritime communication, especially close to shore communication, extending business role models supported by slicing and non-public networks beyond the traditional operator oriented models. Satellite access was added. Non-public networks where 5G technology is used in dedicated networks, such as by factories, enterprise in a campus setting, or building automation. We also added some additional service capabilities. So we enhanced the messaging for 5G IoT. There were a number of V2X enhancements in 5G. We defined precise location service requirements for factory industrial processes. We added support for user-centric identifiers and authentication based on 5G identifiers and authentication. And then the VR KPIs were refined. Next slide, please. So in release 17, this is not all the work that we did, but just the highlights. And a note that the release 17 features were prioritized early in the process, and some were dropped from release 17. Of that set, the stage 1 is complete. Stage 2 and 3 is under development, as you'll hear later. Further feature reduction is possible, but not currently planned. So this is based on the results of the work that SA1 has completed. And if there's any reduction, we will have to go back and reflect that in our release 17 specifications. So we added for verticals, AV production, which is things such as TV production, sports events, electronic news gathering, essentially remote video production. Asset tracking, such as for warehouses or container ports, and critical medical applications. And then additional network service capabilities, we added network controlled interactive services. So next slide. Now this is we've just begun work on release 18. We have a set of projects for release 18, but there may be a few more which are submitted. And if a significant number are submitted and agreed, SA1 will have to undertake a prioritization of the work. And so the list may change. Likewise, the follow-on groups such as SA2, RAN, CT may also require a prioritization, which at this time is unknown, and may also affect change to this list. So what are the current projects that we've embarked on? For additional verticals, there's access to localized services such as arena sports event broadcast. And the concept here, it's a little unclear, but the concept here is that if there's a predominant network, either a non-public network or a carrier that provides coverage in a sports arena, for example, if other users have devices which are not subscribed to that operator, this would provide them the ability to temporarily access some of these sports-related events during the event itself. So, for example, if you went into a stadium and you were not subscribed to the operator that's covering that stadium, there would be a capability where you could temporarily subscribe and get some video feeds or something like that. Timing and synchronization as a service, where networks, 5G networks, could provide timing backup services, such as for smart grid and power network usage. There's also some additional work being done for the smart power grid beyond the timing and synchronization. additional capabilities that are being added, vehicle-mounted relays, AI and machine learning, model transfer and distribution, personal IoT networks, which can include home IoT and wearables, like smartwatches. So that's the current state of how we started with 5G services and how we're building upon them. So as hopefully it's demonstrated that any group or companies that wish to cover some segment that they believe is not currently supported or has certain needs over what 5G currently supports, they can bring in a study item, and we will look at the use cases, consider the requirements and KPIs, and identify those where 5G needs to be extended and work on extending the 5G service definition to support those capabilities. Next slide. So finally, I want to give reference to some relatively new documents that 3GPP is starting to produce, which is a release 15 description, release 16 description. And so this is a summary of all the work items that were developed within that release. And it's a good start from a non-technical perspective to get a sense of what 5G or 3GPP is covering. Right now, it's primarily 5G stuff, but it gives you an idea of, without having to wade through a large number of technical specifications, of what was done in that release in terms of adding capability or enhancing it. And with that, I am done my presentation. Thank you very much, and I'll introduce Puneet Jain, who will be presenting on the system network architecture and core network.
Thank you very much, Greg, and thank you, ATIS, for this opportunity. Hello, everyone. I will talk about system architecture and core network enhancements in 3GPP Release 16, and will also briefly describe Release 17 developments. Next slide, please. Release 16 work can be informally grouped into three big focus areas. The first one is about 5G system enablers for new verticals, which includes things like cellular Internet of Things support for 5G, support for industrial IoTs, vehicle to anything communication. And the second is about wireless and wireline convergence, which includes support for access traffic steering, switching, and splitting. And then there were many other 5Gs enhancements. In next few slides, I will talk about some of these enhancements in more detail. It is also worth mentioning that during Release 16 development, a lot of effort was also spent on stabilizing Release 15 5G system specifications. Next slide, please. 3GPP has done substantial EU-TRAN EPC evolution to enable cellular Internet of Things. In particular, EMTC and NB-IoT have been designed in Release 13 and enhanced in Release 14. In Release 16, CIoT work item focus on enabling equivalent functionality for NB-IoT and EMTC connected to 5GC. This functionality is broadly the same as what has been defined for NB-IoT and EMTC connected to EPC in earlier releases. One of the key optimization was about transfer of small data via control and user plane. Control plane CIoT 5Gs optimization is used to exchange user data between UE and network using NAS messages in both uplink and downlink direction, thereby avoiding the establishment of user plane connection for a given particular PDU session. User plane CIOT optimization was enabled by RRC connection suspend and RRC connection resume procedures in CM idle state. Early data transmission allows sending user data in RRC message 3. And then there was this preferred and supported network behavior where UE can indicate which of these features are supported by the UE and what is its preference. In response, network indicates which of those features it supports back to the UE. Non-IP data delivery and reliable data services was also supported. Reliable data services provide a mechanism for reliable delivery of data between 3GPP and endpoints, which is between UE and NEF and between UE and the UPF. It relies on a RDS protocol, which was defined in technical specification 24.250. Extended discontinuous reception for CM idle and CM connected with RRC inactive was also defined. This functionality enables the UE to reduce its power consumption while still being available for mobile terminating data for certain time period depending upon negotiated DRX cycle value. And various DRX cycle values was defined or basically extended for EMTC as well as for RRC CM connected with RRC inactive state. Enhancement for mobile internet, mobile initiated connection only called MICO mode with extended connection timer, active timer, and periodic registration timer was also supported. High latency communication refers to a mechanism that may be used to handle mobile terminated communication with UE being unreachable while using power saving functions. It is supported by extending buffering of downlink data in the UPF, SMF, or NEF where UE is not reachable. High latency communication is also supported through different application functions notifications. Release 16 also supported monitoring events such as removal of USIM from UE, UE communication failures, reporting number of UEs present in specific geographic areas, and many other monitoring events were supported. There was also support for restriction of use of enhanced coverage, since enhanced coverage can use a lot of resources in the 3GPP system. In addition, rate control for user data, congestion control for control plane data transfer, service gap control to control the frequency at which UE can access the network were also specified. Inter-UE QoS for NB-IoT allows NGRAN to prioritize resource allocation between NB-IoT UEs using control plane CIoT 5GS optimization based on their subscribed UE priority value. Next slide, please. 5G LAN type service provides services with similar functionality to local area networks and VPNs, but improved with 5G capabilities such as high performance, long distance access, mobility, and security. The 5G LAN type service enables management of 5G virtual network, group identification, membership, and group data. The 5G virtual network group management can be configured by a network administrator or can be managed dynamically by third-party application function. In order to support dynamic management of 5G virtual network groups identification and membership, the NEF, which is network exposure function, exposes a set of services to add, delete, modify the 5G virtual network groups and 5G virtual network members. 5GS supports optimized routing by enabling support of local switching at UPF without having to traverse the data through the data network. This local switching can either happen within the UPF or between two UPF via N19 interface as shown in the figure. Next slide, please. Time-sensitive communication. It is a communication service that supports deterministic and/or isochronous communication with high reliability and availability. In release 16, main focus was on integration with IEEE time-sensitive networking. IEEE TSN defines several configuration models: centralized, distributed, hybrid. In release 16, 5GS supported only fully centralized model. In order to support time synchronization, the entire end-to-end 5G system can be considered as IEEE 802.1 AS time-aware system. The TSN translator, in short TT, is located at the edge of 5G system, and it provides all functions related to IEEE 802.1 AS standard. 5GS supports distribution of TSN grandmaster clock information via 5GS with appropriate processing, like a timestamping of GPTP messages in the TT function. Release 16 only supports downlink synchronization. That is, scenarios where TSN grandmaster clock resides on the network side. And there is an work going on in release 17 to also support uplink synchronization. 5GS also supports time-aware scheduling and per-stream filtering and policing capabilities. In release 17, study is ongoing for enhanced support of time-sensitive communication. This includes, as I mentioned, support for uplink synchronization, support for multiple working clock domains connected to the UE, UE to UE TSC communication via same UPF, exposure of network capabilities to support time synchronized communication, and any specific TSC related requirements needed for audio-visual service production. Next slide, please. A non-public network is a 5G system deployed for non-public use. It is also referred as private network or isolated network. An NPN may be deployed as a standalone non-public network, in which case it is operated by an NPN operator and not relying on network functions provided by a PLMN. Or a NPN may also be deployed as a public network integrated NPN. PNI NPN is a non-public network deployed with the support of a PLMN. In release 16, direct access to SNPN is specified for 3GPP access only. That means no non-3GPP access support was defined. Interworking with EPS is not supported for SNPN in release 16. Also, emergency services are not supported. Furthermore, roaming between SNPN and handover between SNPNs are also not supported in release 16. Standalone NPN is identified by a combination of PLMN ID and network identifier. The PLMN ID used for SNPN is not required to be unique. PLMN IDs reserved for use by private networks can be used for non-public networks. For example, based on mobile country code 999 as assigned by ITU. RAN for a standalone non-public network broadcasts PLMN ID and NID in the system broadcast, enabling network selection, reselection, overload control, access control, and barring. Public network NPN are NPN made available via PLMN, example by means of dedicated DNNs or by one or more network slice instances allocated for the NPN. As network slicing does not enable the possibility to prevent UE from trying to access the network in an area where the UE is not allowed to use network slice allocated for the NPN, closed access groups may optionally be used to apply access control. A closed access group, in short referred as CAG, identifies a group of subscribers who are not permitted to access one or more CAG cells associated with the CAG. In release 16, studies ongoing to further enhance support for NPN. This includes enhancement to support SNPN along with credentials owned by entities separate from SNPN, NPN support for video imaging and audio for professional applications, and support for IMS voice and emergency services for SNPN. Next slide, please. In release 16, enhancement for URLLC includes enhancement of service continuity. When a UE moves, the user plane path of low latency services need to be optimized to reduce the latency and to guarantee service continuity. Several related mechanisms are developed in release 16. Release 16 specified PSA relocation for Ethernet PDU session. The target UPF will assist in the update of Ethernet forwarding tables of Ethernet switches in the data network. This is done so that the uplink and downlink traffic will switch to the target UPF when the UE is moved. For uplink classifier relocation, a forwarding tunnel between the old and the new uplink classifier is introduced to avoid packet loss during relocation. Application function influence traffic routing mechanism is further enhanced to allow flexible coordination between SMF and AF when the user plane changes events happen. In release 16, QS monitoring was defined for the measurement of packet delay between UE and PDU session anchored UPF. The NGRAN is required to provide the QS monitoring of uplink downlink packets delay at the UU interface. The QS monitoring of uplink and downlink packet delay between NGRAN and UPF can be performed at different level of granularities. It can be done on per QS flow level, or it can also be done on per GTPU path level. Some URLLC services require a very high reliability, and to support such services, a redundant transmission mechanism was specified in release 16. Different options are specified to support redundant transmission at different layers. Dual connectivity based end-to-end redundant user path was specified. In this option, two redundant PDU sessions with independent user paths are established between the UE and the data network. Packet replication and eliminations are performed at the upper layer of the UE and the data network, which are not specified in 3GPP. Support of redundant transmission on N3 and 9 interface. In this option, for a PDU session used for URLLC services, two redundant N3 and 9 tunnels, which are independent user paths, are established between UPF and NGRAN to transfer the duplicate user packets. Here, the packet replication and eliminations are performed by NGRAN and the UPF. The third one is about support of redundant transmission at transport layer, and in this approach, basically it is assumed that backhaul provides two disjoint transports between the UPF and RAN. The redundancy functionality within NGRAN and UPF makes use of these independent path as a transport, which is not specified in 3GPP. Next slide, please. Release 16 provides support for network automation and data analytics. Network data analytics functions and WDF was defined to provide analytics to 5G core network functions and to ONM. The NWDF consists of several services, which was defined in release 16, and the work is now going in release 17 to further extend them. In release 16, slice load level related network data analytics and observed service experience related network data analytics was defined. NF load analytics as well network performance analytics was also specified. NWDF provides either statistics or prediction on the load, communication and mobility performance in the area of interest. Other thing was about UE related analytics, which includes UE mobility analytics, UE communication analytics, expected UE behavior parameter related network data analytics, and abnormal behavior related network data analytics. The NWDF can also provide user data congestion related analytics. This can be done by one-time reporting or continuous reporting in the form of statistics or prediction or both to any other network function. QS sustainability analytics. This is where the consumer of QS sustainability analytics may request NWDF analytics information regarding the QS change statistic for a specific period in the past in a certain area, or the likelihood of QS change for a specific period in future in certain area. In release 17, studies ongoing for network automation phase 2. This includes some leftover from release 16, such as UE-driven analytics, how to ensure that slice SLA is guaranteed, and then also new functionality is discussed, which includes things like support for multiple NWDF instance in one PLMN, including hierarchies, how to enable real-time or near real-time NWDF communications, how to enable NWDF assisted user plane optimization, and last, which is very interesting, is about interaction between NWDF and AI model and training service owned by the operator. Next slide, please. Release 15 defined 5G core as converged core with common interface towards 3GPP and non-3GPP access system, such as wireless LAN. However, in release 15, only untrusted non-3GPP access network was supported. In release 16, support for trusted non-3GPP access network was defined. The main difference in contrast to untrusted is in a registration procedure, where it is assumed that EAP 5G can be carried between the UE and TNAP directly on access layers. And the example would be IEEE 822.11x. And this is also assumed that between TNAP and TNGF via TA interface, EAP 5G can be carried. So this does not require a support in IQV2 establishment. And from the point of view of other procedures such as session management, and the same procedure is specified for untrusted non-3GPP access can be used, which is basically done by removing TNGF with N3IWF, which is non-3GPP interworking function. Release 16 enhanced 5G core network to support connection of residential gateway connected via wireline access network and via 3GPP RAN access. The main feature includes the specification of new access network node called wireline access gateway function. The support of legacy residential gateway not supporting 5G capability, which is called FNRG, is supported via wireline access gateway function. In this case, it would be terminating N1 NAS interface on behalf of UE and acting as a UE in respect to 5G core. IPT services defined by broadband forum for residential gateway connected to wireline access network and to NGRAN was also specified in release 16. Next slide, please. In release 16, ATIS feature enables multi-access PDU connectivity service, which can exchange PDUs between the UE and the data network by simultaneously using one 3GPP access network and one non-3GPP access network, and two independent N3 N9 tunnels between the UPF and RAN. The multi-access PDU connectivity services is realized by establishing multi-access PDU session. That is a PDU session that may have user plane resources in two access networks. Two ATIS steering functionalities are supported. First one is using multipath TCP functionality for TCP traffic. This includes multipath TCP proxy in UPF and use MPTCP protocol over 3GPP and or the non-3GPP user plane. The second one is ATIS lower layer functionality for all type of traffic, including TCP, UDP, Ethernet traffic. The ATIS lower layer functionality is mandatory for multi-access PDU session for type Ethernet. The performance measurement function supports measurement between the UE and UPF to assist access selection. Some examples are by using RTT measurement per access, or UE reports access availability or unavailability to the UPF. And based on that, the performance measure function supports the measurement. In release 17, study is ongoing for ATIS phase 2, which includes support for additional steering modes with potential PMF extensions, support for additional steering functionality based on ITF protocol, multipath quick, and also it's been investigated that the support of multi-access PDU with one 3GPP access leg over EPC and another access leg over non-3GPP access 5G system can be supported. Next slide, please. Traditionally, application and APIs were considered outside 3GPP scope. But that has changed with the formation of 3GPP SA6 working group, which initially focused on mission critical applications, but has now expanded the scope to other vertical applications such as V2 applications, edge applications, drones, and things like that. SA6 provides a middleware between the vertical applications and the underlying infrastructure. Some of the work includes specification of common API framework called KPIF for unified 3GPP not-bound APIs. Service enable architecture layer, also known as SEAL, was also specified. In release 17, there is work ongoing on enhanced support for edge computing in SA2 and SA6 is looking into enhancement for enabling edge applications. Next slide, please. As we see in that release 15 provide support primarily for EMBB with many innovative features such as service-based architecture, support for end-to-end network slicing, enhanced QoS, network capability support, exposure to third-party application service providers. Release 16 built on it and provided supports for vertical use cases for URLLC, cellular, and industrial IoT. At the same time, providing further enhancement to EMBB features such as UE capability signaling optimization, single radio voice call continuity from 5GS to 3G. I mean, for some of the operators where they did not have a complete coverage using 4G LTE. So this feature was also specified in release 16. In release 17, aim is to provide further enhancement to certain release 16 feature as well as enabling new features and services. Some examples of the work which is ongoing in release 17 to support new features and services include support for multi-use SIM devices, support for unmanned aerial system, 5G D2D or proximity services, 5G multicast broadcast services, support for satellite access in 5G, and interactive cloud services support. At the same time, support for enhancement of release 16 feature, what we call as phase 2, is also ongoing in 3GPP as part of release 17. This includes things like support for edge computing, enhancement for non-public network, TSC and ATIS, which I talked about, and then further enhancement for network automation and 5G location services. With this, I'm going to hand over to Wansi, who will go over the RAN part. And thank you, everyone. Over to you, Wansi.
Okay, thank you. Hi, everyone. This is Wansi. It's a pleasure to be here. As Ian already mentioned, right now in RAN, we just finished release 16, which was a major accomplishment, especially considering the huge challenge we're facing due to COVID-19. Indeed, a lot of meetings that we originally scheduled for this year have converted to the so-called electronic meetings. We are using emails, conference calls to make progress. So I'm happy to say that we successfully completed release 16 just recently. We're now start working on release 17. So today I'll give you an overview of release 16 from RAN perspective. As you will see, a lot of projects that I'm going to go over will have quite similarity with the SI part. It's not surprising, especially given that there's a lot of coordination between SI and RAN groups. Next slide, please. Okay, so on these slides, I try to illustrate how release 16 in comparison to release 15. From day one, the first release of 5G, which is release 15, we try to build a framework such that this new RAD can be future-proof, which can also be easily made backward compatible and future compatible. Here on the bottom, you can see the 5 key technologies, including this flexible slot-based framework, scalable minimology, advanced coding, massive MIMO, and mobile minimum wave. And release 16, we use this foundation we had in release 15. We primarily focus on 2 aspects. One is to fully enhance the foundations of release 15. And then the other aspect, which is probably more interesting, is to expand the reach of 5G, basically to expand to the so-called vertical domain. Here are a few examples. I don't go over one by one. Next slide, please. So we'll start with look at this so-called driving fundamental enhancements, which is the basics that we'll have for release 16. Next slide, please. The first one in Release 16 for these fundamental enhancements is so-called maximum MIMO performance enhancements. As we all know, maximum MIMO is one of the fundamental technical enablers for 5G. This got further enhancement in Release 16 to further improve the performance, efficiency, and reliability. This comes comes at a few aspects. One is the so-called enhanced multi-MIMO. This primarily in the form of how to further enhance the channel state information feedback by providing a better trade-off between overhead and performance. One interesting aspect is the development of the so-called multi-transmission reception points, also called multi-TRP. This basically UE could be possibly served by multiple base stations. This can, in particular, improve the reliability for the UE. Beam measurement is one critical aspect for MIMO operation. So this got fully enhanced in Release 16. In particular, we provide some fast recovery mechanism for the so-called secondary cell in the context of carriagation and beam connectivity. The power efficiency also got fully improved. This is done by reducing the so-called PAPR, this peak to average power ratio. This by using this improved uplink and downlink reference signal. Uplink coverage also got extended. This is in light of different possible implementation on the UE side in terms of how this multi-antenna, the power amplifier could be possibly implemented. In light of all these possible implementations, we did a lot of specification work to make sure we can achieve the full power uplink for these different capable UEs. Next slide, please. Okay, so one important metric for user experience is the power consumption, or how long a battery can last. That is something we try to optimize in Release 16. Actually, to do the work, we did a lot of modeling of how different components, different parts of the features in terms of power consumption. So that's a very detailed modeling to make sure we understand we can also do the design such that the power saving can be achieved. We end up with quite a few techniques that can enable these power efficiency enhancements. One is called a wake-up signal. It's basically to provide a faster mechanism to tell you when to wake up or when to go to sleep. The cross-scheduling provides a mechanism for you to firstly try to decode a control channel, and depends on how the decoding results to decide what to stay on to decode the subsequent data channel or go to sleep. This MIMO reduction, or rather this adaptation, is also one important aspect, such that you can follow the actual traffic need to adapt the number of MIMO layers to better serve the UE at the same time to optimize for the power consumption. There are few also other things like lower power mode groups, the device assisted power saving, and relaxed ready resource management. This is also provide necessary mechanism for you to set powers. And also in the carriagation context, we also provide some low power control, particularly in terms of how to more efficiently activate deactivate the so-called secondary cells from the primary cell. Next slide, please. Another aspect in Release 16 that we enhance is so-called mobility enhancements. This is important, especially for certain services, for example, these URLLC services, and also for some use cases like high speed or high mobility use cases. This is done by using the so-called DAPS, Dual Active Protocol Stack, DAPS. This can enable a so-called 0 millisecond handover. And also there's a mobility robustness improvement that has been introduced to further enhance the mobility management for the UE. Next slide, please. And carrier due to connectivity, this is something rather straightforward in terms of concept, but it's a very important tool to enhance user experience. So it's not surprising that we continue evolving in this aspect. I'm not going to go into details, but just give you some high-level description. For example, for this capability and performance enhancement, we're talking about the possibility to do cross-carrier scheduling using different pneumologies, this single TX switching enhancements, the power sharing whenever you have asynchronous deep connectivity, this online CA, and then you have early measurement, the fast CA/DC activation, and also this fast link recovery in deep connectivity. So all these aspects were introduced to further enhance this CA and DC deployments. Next slide, please. And then, of course, URLLC is always one important aspect. Actually, is one of the three pivotal user cases that we first come up with in the first release of 5G. In combination with EMBB and MTC. So URLLC was already supported in release 15. And in particular, we have something called sub-slot scheduling, which can address the latency aspect, and also have enhanced MCS, the CSI enhancement to address the reliability aspect. But we did further enhancement in release 16, which can be summarized in these 6 different aspects: improve HAC, comp, increased redundancy, inter-device service multiplexing, intra-device channel prioritization, and more flexible scheduling. One thing I want to mention in this improved HAC is just to make sure we could provide more frequent or more possible HAC feedback opportunities within a slot, so that we don't limit ourselves to provide a single feedback per slot. And then also did a lot of work. As you can imagine, this is something actually very complicated in terms of the inter-device service multiplexing, and something also intra-device channel prioritization, because this user, if you look at a particular user that may have different services, how to better address the high priority user case of services, at the same time in light of some ongoing low priority services. Of course, this also may come from different users. So we did a lot of efforts to try to address these different cases. Next slide, please. Another important aspect is the so-called two-step REG procedure. Traditionally, we have this 4-step REG procedure, as listed on the left hand of the figure. You can see that typically we have so-called method 1, 2, 3, 4. It's just to have these necessary steps to perform a handshaking between UE and the Genome B. Now this is being simplified into a two-step procedure. We call it method A and B. Method A basically can provide not just the preamble as in method 1, but also a small payload using POSCH. This could reduce this signaling overhead and also reduce latency, which is very important, especially for small data applications. Next slide, please. And another aspect is the so-called RIM and cross-link interference. RIM refers to the case when the 2 different stations, even 100 kilometers away, if they use different configuration, even with the same configuration, if the gap is not sufficient, it's possible that one link, maybe downlink or uplink, may see interference from another cell using a different link direction. And cross-link is also kind of similar to RIM, but it's more or less referring to a nearby deployment where the 2 different cells may have different configurations. This is possible because the slot structure that we design for 5G is very flexible and dynamic. So different cells can look at its own needs and manage the slot structure adaptively. So we may see this so-called cross-link interference. Basically, one link reception may receive interference from a transmission from a different link directions. So we handle this case by introduce some, the reference signals for you to measure, for you to measure, and then report the measurement and take necessary actions to address or to alleviate this impact. Next slide, please. And then for IAB, as we know, millimeter wave is one very critical aspect of 5G. And by nature of millimeter wave is typically for the small cell deployment. But if you want to connect to these different these millimeter wave nodes using fiber, sometimes it is not even possible, but at least it's going to be very cost prohibitive. So this IAB is to address this case to improve coverage and capacity by using this so-called backbone to connect a GNOB and a relay node, which is also a GNOB node. And then because these more or less a fixed deployment, so of course this IB can also be mobile. Because this more or less fixed deployment is possible to reach further away compared with the access link that the typical GNOB versus UE this service. And this design in 16 actually are very comprehensive. Not only we're talking about how to manage the resources between the backhaul and access link, we also enable this multi-hop capability. And with this thing, we can better serve UEs using this millimeter wave, this frequent band. Next slide, please. And then one interesting deploy scenarios is to have these two different bands. On the left, you can see the figure where two different carriers, where carrier 1 is lower FDD band, carrier 2 is a higher TDD band, which may have some strong commercial interest. And the UE itself may be equipped with two transmission chains, and how to manage the two transmission chains in light of two different carriers and also in light of the dynamic scheduling needs. So two modes were defined, and for the two carriers, you may have 1+1 or 0+2, where the 2 is for the TDD carriers, where you can enable uplink MIMO operation. So we introduced these different modes and the details on how this switching is being done to better serve this deployment. Next slide, please. And then there's additional enhancements. I think this is also connected with some SA presentations earlier. I'll go quickly. So there's also, because of flexibility of 5G and also a lot of capability indications can be possibly indicated by UE. So there's a strong need to address this increase of device capability size due to this, many possibilities of band combinations and features. So here we have two features introduced. One is called uplink RC message segmentation. The other one is called device ready capability ID to address this capability signal. Next slide, please. And also this maintaining continuity with the circuit switch feedback is also one important feature. In particular, the fallback procedures defined from 5G NR to switch 3G FDD network. It also applies to the emergency calls. Next slide, please. And data collection, and also I think it's mentioned by earlier presentation, for network performance enhancements. On the RAN side, there's also a lot of things being introduced. This come from these three different aspects. There's enhanced network automation, the so-called MDT, minimization of drive testing, and some self-organization networks. I'm not going to go into details, but this is also something being introduced with 16. Next slide, please. So I just give a quick review about this further enhance the foundation 5G. Now let's look at how 5G is expanded into vertical domain. Next slide, please. The first one is the introduction of 5G in the unlicensed spectrum, also shared spectrum. These come into two different flavors. One is to use this anchored, so-called anchored NRU in our unlicensed, and the other one is standalone NRU. So this anchored NRU is similar to something we already had in a 4G LTE context. It's called LAR, licensed assisted access. So basically, with this unlicensed spectrum is still somehow tied with a licensed spectrum. Then, of course, probably a more interesting case is to have the standalone NRU, where only unlicensed spectrum is used. And this unlicensed spectrum, although it's never going to compare with the licensed spectrum in terms of reliability, but it definitely unlock more spectrum globally and make it possible to offer even higher data rates and also open new markets and verticals. Okay, next slide, please. And this also mentioned earlier, I believe, these private networks, industrial IoT. I'm not gonna repeat the same information. One thing I want to mention that for this industrial IoT, I think I also mentioned earlier, this timing is very important. It's also something called timing sensitive network. So a lot of work is done there to make sure that the precise timing, including the jitter, all the kind of things, can be well controlled to support these industrial settings. Next slide, please. I think probably one major, probably at least personally, I feel this is something very interesting is to bring this 5G V2X Starlink. This brings new benefits for alternative use cases. Primary focus on V2V and V2I, and there's also new aspects will be coming up in the 17, particularly V2P. And we did a lot of work in a very short time to make it happen. This definitely make it possible to enhance autonomous driving and also to have fast travel energy efficiency and also this accelerated network effect. Of course, the original intention of this to focus on this vehicle related communication, but it definitely can also be used for other use cases, which was also carefully assessed during the 16. For example, public safety, the data offload, all those kind of things. As you can imagine, the Starlink communication is to be further enhanced in release 17, and probably also going to be in future releases as well. Next slide, please. And then one aspect also in release 16 is about position. So we already have the positioning in 4G LTE. In 5G, definitely is something, it's a must-have for 5G as well. And for this, actually, there's a lot of work being done using a variety of techniques to try to have a accurate positioning to meet not just the regulatory requirements, also the commercial requirements. So here, there's some numbers quoted here, like if you look at the indoor, we're talking about 3 meters, outdoor, we're talking 10 meters for 80% of the time. The techniques, including quite a few flavors. You have round trip time, you have angle arrival, angle departure, and this is a traditional time different arrival, being downing or uplink. And you have single cell versus multi-cell positioning techniques. And also there's definitely, just because now the 5G is not like limited to the traditional deployments, there's also new evaluation scenarios that will be modeled in release 16, in particular for the industrial IoT environment. So a lot of it being done in release 16. Very happy to see that. But as you can imagine, further enhancements are still on the way to release 17 to further enhance 5G positioning particularly in terms of addressing latency, reliability, and even more accurate position. Okay, next slide, please. And then broadcast. So in LTE, we already have the so-called MBMS, multicast broadcast services. And now this was further enhanced and starting from release 16, and then many features were introduced along the way. We're talking about different possibilities of broadcast services, including this low power, low tower, medium power, medium tower, high power, high tower, and also different speeds and different deployments, particularly in terms of the range of the broadcast services, many of which it also arrived from different interests in different from different operators. I mean, here you can also see a list of names that supporting these efforts. You can see there's definitely a wider ecosystem support in 3GPP. So that's been introduced with 16. This also can be named a 5G broadcast so that we could deploy this for more diverse deployment scenarios. Next slide, please. And these at one of the also these the 3 pivotal user cases. One, the other one is what I mentioned, URLLC, and now we have the Massive IoT. This was done by further evolving EMTC and neighbor IoT. I assume the audience already understand the differences or the different flavors of EMTC and neighbor IoT. But this was now is in release 16. This was now introduced as part of 5G family by having the possibility of EMTC and neighbor IoT in in-band 5G, in-band 5G cell. This is possible just because, as I mentioned earlier, the 5G firmware was really built to be very flexible and feature-proof. So that's really why the work to make it happen actually is not that major. It's just something minimal effort being done in 3GPP to make it happen. Of course, we also have 5G connect support to make sure this can be also incorporated in the network connect side. Of course, this enhancement for these 2 type of MTC users continually 16. There's a few aspects like group web signal, pre-config uplink, all these kind of things are introduced with 16. And these are also to be fully enhanced in release 17. Okay, next one. I think I pretty much done with my introduction 16. Of course, we all know that 5G is built with a very generic, very flexible framework, which I believe provide a strong foundation for us to fully enhance, fully improve 5G over time. We're now just started with 17. Of course, I'm personally very excited to see how this 18, 19, 20 will look like. For example, there's a lot of discussion about AI, which will be interesting to see how this can be incorporated into 5G family. Of course, almost every 10 years, we have a major leap into a new generation. It'll be also interesting to see how the next generation will look like, especially in comparison or in relationship to 5G. I think that's the end of my presentation. Thank you.
Thank you very much, Wanshi. That was very good. Can we go to next slide, please? And the next one. So very quickly, and we'll have a very short wrap up, and then we'll go to the Q&A. As we've heard, the work in 5G is continuing to evolve rapidly, the technical capabilities of that technology. And in ATIS, we have a very active work program with our members shaping 3GPP requirements and solutions based on North American experience and market needs. And you can see on the slide here the 4 main areas where we focus that. One is spectrum, where we have a lot of US-specific features. One is the 5G vertical market support and a lot of activities, including smart cities and UAVs. a range of general enhancements to system capabilities, including satellite access, which is a major activity in ATIS, and IoT optimizations. And lastly, regulatory features. US is a leader in a number of regulatory aspects, including wireless emergency alert and E911 positioning. And these are all active topics in ATIS today. Next slide, please. And I just want to provide a heads up on a longer term issue. Obviously, in the last few years, the industry focus has been firmly on maturing LTE and rolling out 5G. And as we have seen, 5G will continue to deliver powerful solutions to the marketplace. But recently, we've seen clear signs that the 6G game has begun. Regions are undertaking coordinated 6G research programs with academia and industry. And we are seeing global standards groups, such as the ITU, starting to lay out a next generation requirements and roadmaps. To address this in the North American region, in May this year, ATIS issued a call to action to promote US 6G leadership, which I think has been very well received, both at the political level and the industry level. And we are working with our membership and other stakeholders to form a group where we can have a broad set of regional stakeholders, including industry, academia, and government, contributing to the 6G vision in the region. And we think it's very important to have that broad participation in 6G or next G discussions. Next slide, please. We've also looked at the architectural principles for next generation networks under the heading of the Future Network Enabled Marketplace. In the interest of time, I won't present these, but to say that I think it's important that we do have this architectural vision, and we think this will inform the evolution of 5G networks and the evolution towards the next generation. Next slide, please. So to wrap up with some concluding remarks, I think like all organizations, 3GPP has had to adapt its working methods due to COVID-19. As you've heard today, the amount that has been delivered despite that is impressive, and the drive for innovation is undiminished. I think that we are learning a lot in this process about new methods of working, and I'm sure learnings from that experience will persist after the crisis. We have a rich roadmap of 5G specification enhancements to address the range of use case and operational capabilities. And I think 5G is going to be an extremely productive and valuable technology for many years to come. I'd like to thank their speakers for the excellent presentations. It's really been extremely informative. And now what I will try and do is pick out some of the questions that we've been asked on the question box. We won't have time to address all of them, so if we don't address your question, apologies. But hopefully we'll also be able to address some of the questions offline as well. So one question that's come up from a couple of people, and so I'll throw this open to the floor, is what is the status of release 16 in terms of its quality and its implementability, if I can call it that? And has that been affected by COVID-19 at all? So maybe I'll start with Wanshi, as RAN tends to be the focus for that kind of question. So what's your view on the release 16 quality and the implementability at the moment?
Sure. I mean, as they already commented, this COVID-19 definitely posed a huge challenge for completion work. We, especially at the RAN side, all chairmen were very committed to still completing 16 in time. So originally, the so-called SM-DOM freeze was scheduled to finish by June this year. We still we still managed to achieve this target. But I can imagine, just because of the challenges of using e-meetings compared to physical meeting, the efficiency definitely is not the same, regardless how much we try. So the quality of the June specification, although in my opinion is pretty good, but it's definitely, in terms of S1.1 freeze, that definitely has some room for consistent checking for further modification. Indeed, we just discussed this aspect in the RAN partner meeting, which just finished last week. One topic was actually try to see how we could address, which version of specification that, at least from run perspective, that can be used for the commercial deployments. So we actually, it's at least from the signaling perspective, the June version, which we managed to finish this Ascendant freeze in June, that version actually was commonly understood that this version cannot be used for the commercial deployments. So that something will be added to 3GPP website to clarify that aspect. This including so-called, I'm not sure how the audience are familiar with the specification series. This is 38.331 and 36.331. And of course, we will use the September version instead for the commercial deployments. And then any subsequent corrections or maintenance will be handled at normative work to make sure that we further stabilize the specifications, but not to introduce any unnecessary non-compatible changes. Thanks.
Okay, thanks for that. Does Pete or Greg, do you have any other comments?
No, I think just to add this, Puneet, here, that we do see the challenges with the COVID-19, but nevertheless we making progress. Obviously, it has taken a lot of extra effort to have longer e-meetings. The meetings are being extended for longer durations, and also a lot of emails communication going on. So as you mentioned, Ian, and also your presentation, I mean, it's definitely not as productive as a face-to-face meeting, but we are trying to do our best given the situation. Thanks.
Okay, thanks for that. Another question that's come up, and I'm interested as well, is obviously we hear a lot about Open RAN and ORAN in the technical press at the minute. Is that something that has an impact on the work of 3GPP, or is the 3GPP work essentially already covering the topics that are relevant to Open RAN? Maybe that's, I guess, Wanshi, probably you're the right person to tackle that.
Maybe I probably can ask Janet or Greg to comment this. For this Open RAN, this is because as you know, I'm the RAN 1 chair, not the RAN 2, RAN 3 chair. My knowledge on Open RAN actually limited. I know this is an integral part of 3GPP on the RAN side, but I think probably for more details, probably the other two probably can shed more insights.
So maybe I can provide a quick comment from my perspective. I think that there is a work ongoing in ORAN Alliance on Open RAN, right? And there is other also work going on in the TIP forum as well. From 3GPP perspective, I mean, we are mostly work on the interfaces between the network functions, right? And ORAN Alliance is working on some of the enhancements for architecture, which may have impact on 3GPP. And once that thing is finalized, we will see within 3GPP, as per based on contributions from 3GPP individual members on what those enhancements needs to be defined. As well as the ORAN is also doing this all open source thing, which 3GPP would not have any say on that as well. So a short answer is, when the things gets settled within ORAN Alliance in terms of what network interfaces within 3GPP needs to be enhanced, we anticipate the work would be brought within 3GPP, especially in RAN 2 and RAN 3 working groups by the 3GPP individual members.
Thank you. I think that's a very helpful comment. So I think we have time for one more question, which I will attempt to answer myself. Last question I have is on the timetable for release 18. So my understanding is currently there is no official timetable defined by 3GPP for release 18. And the main activity is in the requirements group SA1, who are collecting proposed work items. So then the question currently is at what stage do we define that timetable and what might be the deadline for new requirements? And I think it will be either at December or after December that the release 18 timetable will be firmly defined. And at least until then, all features that are being proposed to 3GPP are potentially candidates for release 18. But there will have to be a prioritization process to decide what actually makes it into the release. I think that's pretty clear. I don't know whether anybody had any other comments on that release 18 question.
Maybe just to add a little bit more, I think this definitely, you know, is something not decided at point. It's just because the situation is quite unclear. But at the right side, we actually just had quite some discussion in the last round plenary in terms of how to schedule release 17. Of course, the release 18 can only be clear after release 17 schedule is stabilized. We currently assume certain dates, but this is more like assumption used among the chairman, including round plenary chairman and working with chairman. But most likely we'll make a decision in December for the release 17 schedule, and after that we'll know better about how the release 18 will look like in terms of schedule. Thank you.
Okay, thank you very much. So I think, unfortunately, we're out of time today. Thank you very much for all the questions. My apologies, we covered so few of them. We will try and get back to as many people as we can offline as well. I'd like to thank all our speakers again for an extremely informative presentation. It's great to see so much expertise from the ATIS membership in 3GPP, and we really appreciate your contributions to 3GPP's work and, of course, your presentations today. Lastly, I'd like to thank Lois and Katie from ATIS who've worked behind the scenes to make all the technical logistics for today work, and thank them for making that happen as well. We have a number of ideas for follow-ups based on the questions, so we will also be looking to organise future webinars too. But thank you very much for attending the webinar today, and we will make replays and slides available, and we wish you a good week and a good day. Thank you very much. Bye.
Thank you, Brian. Bye.